One thing to pay special attention to in the quadratic formula is this square root part. This square root part is going to have a big effect on what happens when we solve the equation. Why? Well, there are a bunch of things that could happen, right? Maybe we're solving this quadratic equation. What happens? Well, we get x equals negative 8 plus or minus root negative 8 squared minus 4 times 1 times 16 all over 2 times 1. Oh, when we do this arithmetic, we get 0 inside the square root. What's the square root of 0? Right, it's 0. So 8 plus 0, 8 minus 0, does it make a difference? No. I only have one solution, namely 4. Maybe I'm solving this quadratic equation. I'll get x equals negative 7 plus or minus square root negative 7 squared minus 4 times 1 times 12 all over 2 times 1. When I do this arithmetic, I get 1 inside the square root. So that's 7 plus or minus 1 over 2. Square root of 1 is 1. This is 7 plus 1 is 8 over 2 is 4. 7 minus 1 is 6 over 2 is 3. So here I got two whole rational numbers with no square roots in them. Here I got exactly one number. Maybe I want to solve this equation. I'll get x equals negative 5 plus or minus the square root 5 squared minus 4 times 2 times negative 17 all over 2 times 2. When I work out this arithmetic, negative 5 plus or minus the square root of 297 over 4. This simplifies a little bit. 297 turns out to be 9 times 33. So this is 3 root 33. But these solutions all have square roots in them. There are two solutions, but they're both kind of unpleasant decimals. The last thing that can happen is, well, if I go to solve this equation, I get x equals negative 3 plus or minus the square root 3 squared minus 4 times 1 times 9 over 2 times 1. When I work out this arithmetic, what do I see here? I can't take the square root of negative 27 with the numbers I've got right now. I don't have any numbers that when I square them give me negative 27. Maybe I have no real solutions. So those were 4 different things that could happen. I had no real solutions at all. I had 2 real solutions and they were irrational. They had a square root that I was stuck with. I had 2 real solutions and they were rational. Or I only had 1 real solution. And the only thing that decided what was going to happen was what went on in this square root part. Because it determines which behavior we're going to see, we call the thing inside the square root part the discriminant. And it determines which one of the possible behaviors we see. If b squared minus 4ac equals 0, we have exactly one solution. If b squared minus 4ac is a positive number, we have two real solutions. If it's a perfect square, well, then they're rational. Otherwise, they're not rational. And finally, if it's negative, then we have no real solution. So we have one real solution, two real solutions, or no real solution, depending on the value of the discriminant. And sometimes that's all we want to know. Sometimes all we care about is, how many real solutions does the equation 5x squared minus 17x plus 2 have? To answer that question, we calculate the discriminant. Right? So we'll have negative 17 squared minus 4 times 5 times 2 is 249, which is positive and not a perfect square. So since 249 is positive, the equation has two real solutions. I'll have you try one of these. How many real solutions does the equation 9x squared minus 30x plus 25 equals 0 have? Pause the video and try this now. Alright, so we'll calculate the discriminant. Negative 30 squared minus 4 times 9 times 25. That'll be 900 minus 900 is 0. The discriminant is 0. That means we have one real solution.